Hello students, today we will discuss onto function. F from A to B be any function and is said to be onto. Simple condition I will tell. Every element of codomain have at least one preimage in domain. For example, F from A to B, for some mapping, I will take some elements A, B, C, D in domain and P, Q or some elements in codomain. Now A to P, B to Q, D to R. Observing this mapping is onto function. Why? Because here every element of codomain have preimage. Observing here, the preimage of P is A and Q, B and C also, or preimage D. So every element of codomain have at least one preimage in domain. That means here no free elements in codomain. Then F is said to be onto. In this case, F is onto. Okay. Now one more example I will give. A, B, C, D some elements in domain and P, Q, R are elements of codomain. A to P, yes, very clear. This is also function but not onto. Why? Because the element R have no preimage in domain. R is the free element in codomain. That's why here F is not onto. Clear? Now from these two examples, one more important observing point. What about range of the first function? What about range of this function? Very clear. F of A is equal to set of P, Q, R. This is the range of this function. Again from range of the second example. Set of P comma Q. This is the range of this function. One observing point here in the first example, the range of the function is equal to what? Very clear, codomain. And range of second function is subset of its codomain. Observing here, the range of the function is equal to codomain of the given function is onto, and here the range of the function is subset of codomain of the given function. F is not onto. That's why one condition I will tell now. F from A to B be a function and is said to be onto if F of A is equal to B. That means the range of the function, the range of the given function is equal to codomain of the given function. Then F is called onto function. This is the condition. F of A equal to B. That meaning is what here? No free elements in codomain or every element of codomain have preimage in domain of the given function. Okay, one more example I will give. F from R to R. F from R to R defined by f of x is equal to x square plus 1. F of x is equal to x square plus 1. Is the function onto or not? Just observing here, Here one condition are given, the range of the function is equal to codomain of the given function, then f is said to be onto. Now you will try to identify what about range of this function. Immediately you should observing what about domain of the function. Very clear, domain is what? Set of all real numbers. Now we will try to identify range of this function. Okay, for x belongs to R implies x square is greater than or equal to 0. Always non-negative. Okay, that implies very clear x square plus 1 is greater than or equal to 1. X square plus 1 means what? F of x. F of x is what? Greater than or equal to 1. That means every element of domain related or connected to either 1 or more than 1 in codomain. That's why range of f is left close, right open, 1 comma infinity. This is the range of the given function. Because every function value is either 1 or greater than 1. But what about our codomain of the given function? Set of all real numbers. This is not equal to R, codomain. What is our condition for onto function? Range of the function is equal to codomain of the given function. But here both are not equal. Therefore, f is not onto. Okay, right. Now I will give formal definition. For f from A to B be a mapping and is said to be onto. Suppose sometimes here we can't identify range of the function directly. In that case, how to verify? The given function is onto or not onto. Okay, observing account of definition, for any y belongs to codomain, there exists some element x belongs to A such that f of x equal to y. Okay, for any y belongs to B, there exists an element x belongs to A such that f of x equal to y, then f is onto. Observing here, A, B, f is a mapping from A to B. I will take y. Y be any element of codomain. Okay. Suppose here for some element x in domain. Its image how to write? F of x. The image of x will exist in respect to codomain. So very clear, x is connected with f of x. Suppose let this is y. What is the pre-image of y is x. What is y here? Any element in codomain. Any element in codomain. That means is what? Here every element of codomain have pre-image in domain. That's why f is onto. Okay. In some problems here, we should apply this process. We should take any element y from codomain. There exists some element in domain. Its image is equal to y. That means what? Here no free elements. That means no free elements in codomain. Then f is called onto. Okay. Now one more example I will give. F from R to R defined by f of x is equal to x cube plus 5x plus 1. Is the function onto or not? Here also observing always before identifying the function is onto or not onto, domain first. What are domain of the function? R. Okay. Now here, first here we should differentiate given function. What happening? 3x square plus 5. Very clear. 3x square plus 5 is greater than 0 for all x belongs to R. Very clear. We will take any element from domain f dash of x value greater than 0. In the last video, I told here the given function, the derivative of the given function is strictly greater than 0 or less than 0. That means what here? Increasing or decreasing. Then f is said to be 1, 1. Also in this case here, very clear, f is 1, 1. Of course here, f of x is what? Polynomial function. Every polynomial function is continuous. And present function is what? Strictly increasing throughout respective domain. That's why identify now as x tends to minus infinity implies its corresponding functional value tends to minus infinity, and as x tends to plus infinity implies its corresponding functional value tends to plus infinity according to our given function. Understood? Right. Therefore, the range of f is what? Set of all real numbers. So now observing here, the range of the given function is equal to what? Set of all real numbers. That is the codomain of the given function. That's why, therefore, f is onto. Okay. Now, remaining models, remaining problems on onto functions we'll discuss in the next video. Thank you.